In a previous example, I showed how we were able to go from a function to its inverse. And this was the second part of that problem, where what we want to do, here we go, I was looking for my paper there. I went from the original function to the inverse. And that's what I have written here. I have the original function, its inverse. The specific directions for the problem is for us to find the solution set to when g of x is equal to the inverse. And to do that, this actually is going to call up some higher level math, and that's really the aim of what I want you guys to do in pre-calculus. I want you to be exposed to some of these higher ideas. The more methods that you have, the more powerful you become when it comes to solving equations, solving problems, and thinking logically. And so the first thing I want to do is literally set these equal to one another. So I take this piece, set it equal to that piece, set the original function equal to its inverse. And that gives me all this right here. Now when I have that, the next thing I did was take this exponent of 1/3 and wrote it into its radical form. It's the cubed root of x minus 3. We had talked about doing substitutions earlier, and so what I did in this problem was said, let w equal the cubed root of x minus 3. Now at this point you may be asking, well, why would you do that? Why couldn't I just solve this? Well, I want to show the work on it. I want to show that there is a method for solving this. And from one of those previous examples, we also talked about using that polysmlt 2 application. In order to use a polynomial root finder, you have to have a polynomial. This is not considered a polynomial. You can't have a cubed root on it. And so by me saying let w equal the cubed root of x minus 3, I can solve just this part. I can work with this and say, all right, let's cube both sides. So w cubed becomes x minus 3 because I cube both sides. Then I could move the 3 over and say w cubed plus 3 is equal to x. Now the value of doing such a thing is that now I can come back and I can rewrite all these things. So I have 4 minus, and I'm going to go back to the exponential form here, w cubed plus 3, I'm replacing this x, minus 3, raised to the 1/3, equaling, now on this one I'm going to have to replace that as well, so I'll say 4 minus, I put my parenthesis here, x is the same as saying w cubed plus 3. And that was going to be raised to the 3rd power, plus 3. Once I have this part here, I want to simplify a little bit. As I simplify, notice that I have these inverses in here. So positive 3, negative 3 drops out. That would give me 4 minus. This would be w cubed raised to the 1/3 because the 3's dropped out. W cubed to the 1/3 is the same as saying w. On this side, this would be negative w cubed minus 3. As I distribute that. Negative w cubed minus 3. 4 minus 3 would just be 1. So I could write this as 1 minus w cubed. Again, because that was 4 minus 3, which was 1, and that was going to be negative w cubed, plus 3. Still not anywhere where I can do anything. And so the next step is I have to expand this cubic. I could write this as 4 minus w equal. Remember, when you expand a cubic, it's going to be a cubed. So 1 cubed is 1. Plus 3. A squared would be 1 squared, which is 1, times b. Now b would be negative w cubed. So I'll have a negative w cubed here. Plus 3 times a, which would be 1, times b squared. Now b squared this time would be negative w cubed squared. And then the last part of my expansion would be this term raised to the 3rd power. So negative w cubed would be minus, because 3 negatives would be negative, w to the 9th plus 3. And the next to last step here is just to move everything over, turn it into a polynomial that we could work with. So I'm going to move the most powerful term over, call it w to the 9th. I guess I should say what these are going to be. This would be 1 plus minus 3w cubed plus 3w to the 6th, because negative w cubed squared becomes positive, and then the 3 times 2 is 6, minus w to the 9th plus 3. So, once again, I'm taking this over. This comes over as w to the 9th. I look at the next term. This would be minus 3w to the 6th plus 3w cubed. And I've got this minus w here. That was already over there, so we leave it there. The 1 and the 3 would give me a 4. It would go over as a negative 4, so that drops out. I can simply go equals 0. My first step then, because just like we did before, when you do a substitution, I can find answers for w, but w was not part of the original problem. I'll have to go back and substitute that back in to this part right here. And so my next step, as I look at this, I recognize that I could pull a w out. I can go w times w to the 8th minus 3w to the 5th plus 3w squared minus 1 equals 0. Case 1, w is 0, so I just found an answer. And then you say, well, what about the rest of that? The rest of it can be found by using that polynomial root finder. So I turn my calculator on, and I go to my apps button, polysmlt 2. I'm going to hit enter, and I'm going to do the polynomial root finder. The degree is 8, as I already know this answer, so I'm only concerned about this thing here. So I want to do something raised to the 8th. Next step, and I have to fill in all these things. I have a coefficient here of 1, so I'm going to go 1 for something raised to the 8th. I don't have any 7 power, so I hit 0. I don't have any 6 power, so I hit 0. My 5th power is negative 3, so where it says A5, I'm going to go negative 3. Please make sure you use your negative and not your minus button. I don't have any 4th power. I don't have any 3rd power. I do have a 2nd power, something raised to the 2nd power, so that A2 would be a positive 3. No w to the 1st power, so that would be a 0. And then my constant is negative 1. And I'm going to tell it to solve. Takes a second, it's thinking. Yours will probably take a few seconds as well. There we go. Now we got all kinds of answers here. Now, some of your calculators, it depends on what mode you have set up, it'll say unreal or non-real answers. I don't care about any of these. They're non-real answers. But I do care about these other ones here. And so that's what I'm going to list out. I'm going to list out the x equals 1. So in this case it would be w equals 1. W equals 1.15, we'll call it 4. We'll keep 3 decimals in all of our answers. And then I've got a w equaling 0.682, round those appropriate please. And the final one was w equaling negative 0.536. So I got all those answers right there that I'm concerned with. The w equals 0 came from when I first pulled a w out. And the last step would be for me to go back and plug all these w's in so I get x values. Now notice that when I solve this right here, I had w cubed plus 3 is equal to x. That's where I'm going to substitute all these in. And so the first one would be, I'm looking here, but I'm looking with this value. 0 cubed plus 3 is equal to x. So 3 is equal to x. There's one solution. The next solution, I'm going to plug a 1 in there. So I go 1 cubed plus 3 equals x. So 1 plus 3 is 4. 4 is equal to x. And then I'll have to use the calculator to get these last 3, but at this point I think you'd understand what you need to do. You're going to go 1.154, cube it, add 3, and get your x. I might as well do it. I've went this far. So I'm going to go 1.154 raised to the 3rd plus 3. And I get 4.537. We're going to just go to the 3rd decimal, round appropriately. And then you do the next thing here with this 0.682 and the next one with negative 0.536. And we're going to find 5 answers. We'll end up getting 5 answers. We got 2 nice ones, 3, 4, and then we'll get this. We'll plug this in. We'll cube it, add 3. That'll be another x. We'll plug this in, cube it. Yes, you have to put the sign in there because a negative cubed would produce a negative result. Add 3, get an answer. And then you could list all 5 of those answers from least to greatest. And that gives you the ability to find where the original function was equal to its inverse. Kind of a unique problem.